Pilot is a free online tool that allows you to measure the static rollover threshold, or SRT, of your vehicle. SRT is a crucial procedure which allows us to measure heavy vehicle rollover stability. SRT has been linked to accident rates of heavy vehicles and allows us to measure how likely they are to roll over. When you load up the Payload Pilot website, you'll be greeted with the welcome page. Here you just need to fill in a few personal details, as I'm doing now, to provide some info for your simulation. Note that the email address is very important, as the results will be emailed there. You'll also be asked to select the type of combination that you'd like to simulate. In this case, we're doing a prime mover and semi-trailer. And since we're calculating the static rollover threshold, we'll leave the default output type set to that. Let's proceed to the simulation input page. The first section will be for the body of the prime mover. Here we can either estimate or specify the sprung tear mass if it's known. Note that if you're ever unsure about any of the inputs here, the information mark here will provide a link to a help page that explains everything you'll need to know. Let's just leave this as estimating the sprung mass. Next, we'll want to specify the front axles and suspension. This on a prime mover is the steer axle group. We'll use a common value for the axle group weight of 6,500 kilograms. And we only have one axle in this case. Select a common tire size of 295/80 R22.5. And we'll take a predefined suspension setting, generic steer air suspension with high stiffness. For our rear axles and suspension, or our drive group on the prime mover, we'll use a standard value of 17,000 kilonewtons and 2 axles. Here we'll select 11R 22.5 tires. Because we have multiple axles, Payload Pilot gives you the option to specify suspension per axle or use the same suspension for all axles. We'll just leave it on the same suspension for each axle here. This time we'll choose high stiffness generic drive air suspension. That's our prime mover done. Let's move on to the semi-trailer. For the body, we'll pick skeletal. This is the body type that we use with container payloads. Once again, we'll allow Payload Pilot to estimate the sprung tear mass and estimate the sprung tear mass centroid height from the ground. This is based on the floor height of the skeletal body. Common value for this is 1405 millimeters. Next up, we'll need to input the axles for the trailer. This is the rear axle group. We'll use a common value of 22,500 kilograms with 3 axles and 11R 22.5 tires. Once again, we'll keep the same suspension for each axle group. For trailers, there's a few more options. For a skeletal trailer, generic trailer air suspension with underslung configuration and high stiffness is a reasonable selection. For our payload, we'll estimate from the payload floor and maximum height. We'll use the same 1405 value that we used for the skeletal floor height before, and we'll use the maximum legal payload height of 4,300 millimeters. And that's done. Now we'll submit the calculation. Let's take a look at a more advanced usage of Payload Pilot. This time we'll be looking at advanced suspension options on the trailer. Again, we'll be looking at a prime mover and semi-trailer with a container payload, but this time we'll be using a quad axle group on the trailer. Let's proceed to the simulation. Once again, we'll use common values for the prime mover and not make any changes here. For our trailer, the body type will be the same. Skeletal with a floor height of 1405. The suspension is where it gets a bit different. For a quad axle group, we can have up to 27,000 kilograms on the group with 4 axles and 11R 22.5 tyres. This time we're going to specify suspension per axle. This creates 4 separate inputs, one for each axle that we've selected. First off, we'll select generic trailer underslung high stiffness, just like we did before. And we'll do that for the first 3 axles. For our 4th axle, we're going to set this up as a steerable suspension. Payload Pilot also has generic trailer suspensions with steerable data available, such as this one. But in this case, we're going to use the advanced inputs. For users with detailed information about their suspension performance, they can use these advanced inputs to input them. Typically, this data is usually only available from manufacturers, though some of it may be taken by measuring the suspension geometry. When you select the advanced inputs, these inputs will appear and will be pre-populated by the values used by the generic options. For example, if we change to a different generic trailer suspension, the values here have changed. Let's go back to this generic self-steered suspension. In this case, let's say that we've measured our suspension and we know that our suspension track width, the distance between the centers of the tires on the axle, is actually 1900, and our lateral spacing is 1750. These wider spacings will typically improve results of our SRT simulation. With that done, we can finish off inputting values for our payload and send this off to be simulated on the Payload Pilot server. When your simulation is complete, you'll be emailed a PDF report with the results of your simulation, as well as the inputs used to reach that point. Here's a PDF report of a simulation that we completed earlier. As you can see, the result here for this vehicle is 0.31 G. Vehicles typically get a value between 0.3 and 0.4 G, depending on the vehicle configuration and the type of payload that they're carrying. In some cases, you might find that the result that you get from your Payload Pilot simulation is less than what you need. If this is the case, there's several steps that you can take to improve the SRT result. If your vehicle is already in production, you can look at certain aspects such as reducing tyre size. Smaller tyres lower the overall payload centroid height of your vehicle, meaning that it's less likely to roll over. If your vehicle is still in the design phase, you can look at other choices in the design of the trailers, such as lowering the floor heights or fitting stiffer suspensions. Stiffer suspensions typically result in a higher payload height or better SRT result. If none of these are options, you may need to consider reducing payload height or payload mass in order to achieve the desired rollover stability. In addition to the SRT result of your vehicle, Payload Pilot also calculates safe speeds to complete turns at various turning radii. I hope this video has been helpful and will provide you assistance in using Payload Pilot. If you ever have any questions, feel free to reach out or look at the Payload Pilot manual on the Payload Pilot webpage. Thank you.